All right, we are going to get started with the proofs, really getting into proving stuff at this point. We just finished our quiz, our first quiz in Unit 2, when we were dealing with all kinds of statements, negating the statements, um, counter examples, et cetera, et cetera. Today, we're going to get into the properties of equality, and we're going to start proving things. But today, we're only going to be working with algebraic proofs. And what's good about starting this way is it gets you back into thinking about what the properties of equality are in an area that you're pretty familiar with. You know how to solve an algebraic equation. So we're going to start with the properties of equality. Okay, so these should feel pretty familiar to you when we go through all this. So if I said for the addition property of equality, if I said A, if we're going to say A equals B, then A plus C is going to be equal to B plus C. If we add the same thing to both sides, it remains equal. If A and B are the same number and we add the same thing to it, it should still be equal. And this is a property of equality. All properties of equality, this right here, means there is an equal sign there, okay? There will always be an equal sign when we're using these. Okay. You can't, if there's no equal sign, you can't use a property of equality. That's all there is to it. So just like the addition property of equality, we have the subtraction property of equality. And it also runs the same way. Let's do this. So if I say A is equal to B, and then I say A minus C is going to be equal to B minus C. Okay, so if we have two numbers that are equal to each other and we subtract the same number from both sides, it stays equal. The multiplication property of equality. We start with our friends A equals B. Let's say we wanted to multiply both sides. So A times C is going to be equal to B times C. If I multiply both sides by the same number, it should stay equal to each other. And we also have the division property. So if I start with two numbers that are equal to each other, I say A equals B, and I divide both sides by the same number, then I should get the same, it should stay equal to each other. So that would be A divided by C is going to be equal to B divided by C. Right. And our old pal, the distributive property. So if A is going to multiply B plus C in parentheses, then then we're going to do that. Remember when we would use these little arrows that would go like this? We would say, hey, we're going to multiply like that. It would be AB plus AC. Okay, just multiplying it straight out there. Now, this is where substitution is one that everybody uses, but we never really think about it. So if I said A is equal to B, then A may be replaced by B. We use the substitution property of equality when we substitute our value for x back into the original equation. We now know that x is equal to that, whatever that number is. So we replace it, we substitute that number back in for x. The reflexive property is really for any real number A equals A. All right. I know that sounds like ridiculous. Like we shouldn't have to say that. We know A equals A, but there are times that it actually will come in quite handy. The symmetric property basically allows us to flip things around. It says, hey, if A equals B, then b equals a. And when we do this, is say we solved a long equation and we got 3 equals x. When we flip that around to be x equals 3, that's what we're talking about. We're using that symmetric property. It's saying that I can write it in either order, and it really won't make any difference. Now, the transitive property is a fun one. So if I say if A equals B and B equals C, then A equals C. Okay. We kind of did this when we were using the law of syllogism, right? We would have that middle piece that would sort of evaporate, you know? So this is saying that if A is equal to B and B is equal to C, then I know that A is equal to C. So if, say we're just subbed in a number, 7 equals 7, say A and B are both 7, and then 7 equals 7, and then, hey, 7 equals 7. That's all it's really saying. Okay. So we're going to go through and name that property. Naming that property. So it's not always going to look like cute little A's and B's like we have it up here. We have to learn to recognize it in the wild. So we have all of our properties written right here. We've got the letters A through I, and we've got a ton of different statements on the other side that we need to go through and figure out. So if K equals 3, then 3 equals K. All we did was switch the order. Which one was that when we just switched the order? It was either reflexive or symmetric, but symmetric allows us to flip the order. So symmetric property is H. Right. If 2x equals 14, then x equals 7. Well, how did I get from this statement to this statement? I had to do one specific action. I had to divide both sides by 2. So that means I'm going to use that division property. Right? We're really just talking about how did you get from one side to the other? How did you get from one space to the other? What action did you do that maintained that equality? 4 equals 4. Well, that's that reflexive property, right? It seems like it's a no-brainer, like we shouldn't have to say these kinds of things, but when we're doing proofs, we sometimes do. It is what it is. So if negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. Well, how did I get from here to here? It looks like they added 1 to both sides. So that would be the addition property of equality. All right. If 10a equals 2b and 2b equals c. Right. So 10a equals 2b and 2b equals c, then 10a equals c. Well, we know that these are equal, and we know that these are equal. So I know that the outsides are equal. That's that transitive property. This one, if negative 7 times the quantity x minus 4 equals negative 7x plus 28, that is that distribution property, right? We use that distributive property to distribute the negative 7. So that's going to be E. All right. If 6y equals 24, then 6y minus 3 equals 24 minus 3. It looks like we have two things that are equal, but then we subtracted the same quantity from each side. So that's going to be that subtraction property of equality. If 10x plus w equals 41 and w equals 1, then 10x plus 1 equals 41. It looks like all they did was, they said, hey, if w is 1, I can substitute 1 in for w. So that's going to be that substitution property. If y divided by 2 equals negative 10, then y equals negative 20. How did I undo y divided by 2 to get y by itself? Well, it's always that inverse property. I had to multiply both sides by 2, so it's going to be that multiplication property of equality. 3x equals 2y, and 2y equals z. Then 3x equals z. That's that transitive property, right? These guys are equal, and then these guys are equal. So we can cross out the middleman, 3x equals z, that transitive property. If 7m equals 35, then 7m plus 4 equals 35 plus 4. Well, we started out with two things that were equal to each other, and we added the same thing to them. That's that addition property. All right. If negative 2x equals 18, then 18 equals negative 2x. All we did was switch the order. That's that symmetric property. Given 3x squared plus 1, if x equals 5, then 3 times 5 squared plus 1. Well, all we did was say, I've got an x, and I know x is 5, so I'm going to substitute that in. That's the substitution property, which is f. If m equals negative 2, then 8m equals negative 16. So what did we do here? We multiplied by negative 2, but we also substituted in. I'm going to go with substitution here. That is f as well. 10y equals 10y. That's just that reflexive. Remember, reflexive, think of reflective. It's almost like it reflects itself. G. And last but not least, 5x plus 8x equals x times 5 plus 8. All that is the distributive property, and that is E. It's just the distributive property backwards, right? So we could use that symmetric property, right, to bring that in for us.